Hello, welcome to Unit 2 of Physics 1. I hope you did your test 1 well. Let me know if you have any questions or concerns. We will start Unit 2 by looking back at Unit 1. What did we do in Unit 1? We discussed the case of particle motion. We talked about displacement, velocity, acceleration, and so on for particles that are in motion. Therefore, in this unit, is it reasonable that we ask the question, what is it that makes particles move? What is responsible for making things move? Well, you notice that there is a car here which is at rest, and it is going to sit there at rest as long as there is no net force on it. Now, the moment I apply a net force, the car will move. So tell me, what is responsible for making an object move? An object moves when there is a net force acting on it. How about if that object is already in motion? If an object is already in motion, it will continue in that state of motion unless there is an unbalanced force acting on it. That means the state of rest of an object or the state of uniform motion of an object can be changed only and only if there is an unbalanced force acting on the object. Now, what is the meaning of unbalanced force? Now, when I take this mass on the scale here, this mass now has no unbalanced force. It has a force, the earth is pulling it with a force, and I'm holding it with the same force. Now, there is no unbalanced force. Why? Because the force with which the earth is pulling it is balanced by the force with which I am supporting it. Now, the force I am supporting it is upward. The force the earth is pulling it downward. And here the forces are balanced. The moment I let it go, I am no longer supporting it. There will be an unbalanced force. And there it falls. The unbalanced force made it move. So, you need to understand the meaning of an unbalanced force. Okay, that means it is an unbalanced force that sets an object in motion. You have an object here, an unbalanced force will make it move. An unbalanced force acting on an object in motion will change its state of motion. If you watch people play soccer, a soccer ball coming towards a player is in a particular state of motion. In other words, it has a certain speed in a certain direction. Now, have you seen players heading the ball into the goal post? What the person is doing is applying a force on a moving object to change its state of motion. So a moving object will continue in its state of motion unless there is an unbalanced force. An unbalanced force acting on a moving object. Now here you saw the object moving from the left. Well, I don't think you can see it. It is moving from the left, and unbalanced force now changes its state of motion. Alright, so an unbalanced force changes the state of rest of an object or it changes the state of motion of an object. And this statement is called the first law of motion. So how can you define the first law of motion? We can say an object will remain in its state of rest or in a state of uniform motion unless an external unbalanced force acts on it. An object remains in its state of rest or in the state of uniform motion unless acted upon by an external force. It is an external force that is responsible for either putting an object in motion or changing the state of motion of an object. Now, a force is a vector quantity. It has both magnitude and direction. You see, we haven't defined force yet, have we? Do you know what a force is? How do you define? You know that a force can be used to bend objects. A force can be a pulling or a pushing. You can see all kinds of things you can do with force. If I ask you to give me a definition of force, what would that be? We can actually use this statement to define a force. I can say a force is something that will change the state of rest of an object, or force is something that will change the state of motion of an object. Well, if you put it together, we have a definition of force. And you know force is a vector quantity. Why is force a vector quantity? Because a force has both magnitude and direction. Now, if I told you I applied a 50 Newton force on this mass. Now, did you understand what that 50 Newton force is? I can push the mass up, I can pull it down, I can lift it, I can squeeze it. You see, unless I mention the direction in which the force was exerted, you did not understand what that force actually did. So force, the description of a force is not complete unless its magnitude and direction both are specified. That means force is a vector quantity. And all the rules for vector addition is used for adding forces, and we will be using that in this lesson. Adding forces, we will use the rules for vector addition. So have you defined force? What is there for force? Force is something that will change the state of rest of a particle or change the state of uniform motion of a particle. Let's now talk about the concept of inertia. What does inertia mean? It is something that we normally use in our daily life. Is that right? It's a common vocabulary word, inertia. Or that person has immense inertia. Means it is very difficult to get him to do something. It is very difficult to change him. If he is doing something, he wants to keep on doing that. If he is sleeping, he wants to keep on sleeping. You see that? That person has great inertia. In the absence of an unbalanced force, an object at rest will continue in that state of rest. An object in motion will continue in that state of motion. Isn't that inertia? Yes, an object at rest would want to continue being at rest. An object in motion would want to continue being in motion. And that is what we call inertia. Now, this property is what we call inertia. Now, since Inertia is a tendency to resist the change of rest. Now remember, if I want to change the state of rest of this object, I need to apply a force on it and lift it. And remember, when it is at rest, its velocity is zero. The moment I move it from its rest position, I am changing its velocity. And you know, when the velocity changes, there is acceleration. That means whenever an object at rest changes its state of rest, an acceleration occurs. Similarly, whenever an object in motion changes its state of motion, an acceleration occurs. So, if inertia is the tendency of an object to resist change, changing from the state of rest or changing from the state of motion, we can say inertia therefore is a tendency to resist acceleration. The tendency of an object to resist acceleration is called inertia. Okay, that is a good definition of inertia. And therefore the first law of motion is also called the law of inertia. The first law says the tendency of an object to remain at rest or remain in the state of motion will continue unless there is a net force acting on it. So the state of inertia can be broken only by a net force. Is that right? You know, if you have kids, the only way to break the inertia of the sleep of a kid is to use a net force, pull the cover or do something to get him up. Well, that is not really what we're talking about here. Now, law of inertia, which is the first law, helps us to define force. And what is the definition of force that we have been talking about? Now, a force is something that changes or tends to change the state of rest or of uniform motion of an object along a straight line. So the first law of motion, which is the law of inertia, helps us to give a definition of force. Now, if somebody asks you, what is a force? You can now give an answer. Can you give me an answer? What is the definition of force? Force is something that will set an object into motion or change the state of motion of an object. Without a force, you cannot do that. All right. Now, watch here an illustration of inertia. Why does that ladder fly off from that truck? Well, because the ladder has been in a state of motion and suddenly the truck is brought to a stop. The ladder doesn't want to stop because the law of inertia says if something is in motion, it wants to keep on being in motion. So the ladder that is moving would want to keep on moving. This is an example that is very familiar to you. Look at this one. Some of you must have experienced this. If you are on a motorbike and the motorbike is suddenly brought to a stop by something, well, you have been moving with the motorbike. If the motorbike is brought to a stop, you are going to continue moving. This is a good example of inertia. Why does the man behave like this? Because he wants to keep on moving. And that is inertia. Well, one more example. I know you are tired of these examples. All these are familiar examples. When the car is suddenly brought to a stop, the man who is not wearing a seatbelt will want to continue moving. He wants to obey the rule of inertia. Okay, let's now talk about the second law of motion. So far we were talking about the first law of motion. The second law of motion. Now, if the first law of motion enabled us to define force, we are going to use the second law to measure force. We haven't really come across a way to measure force. This is where we're going to do measuring force. Now, tell me, what is the function of a net force? What does a net force do on an object? A net force produces acceleration on an object. Whether the object is at rest or in a state of motion, the function of a net force is to produce acceleration. So when an object begins to move, it has acceleration since its velocity changes. In the same way, when an object changes its state of motion, it has acceleration because its velocity changes. Whenever there is a change in velocity, there is acceleration. Now, whenever an unbalanced force acts on an object, in other words, when a resting object begins to move, it happens only when an unbalanced force acts on it. A moving object changes its state of motion only if an unbalanced force acts on it. So what does an unbalanced force do? An unbalanced force produces an acceleration. Whenever an unbalanced force is acting on an object, that object will accelerate. And that therefore leads us to the second law. What does it say? The second law is a direct relationship between the unbalanced force and the acceleration that produces on an object. And this is the statement. The unbalanced force acting on a particle is proportional to the acceleration it produces on the particle. That means you apply a greater unbalanced force, it will produce a greater acceleration on a given particle. So if you have a given particle of mass m kilogram, if you keep on increasing the unbalanced force, the acceleration also will keep on increasing. If you decrease the unbalanced force, the acceleration will decrease proportionately. So the statement of the second law, the unbalanced force acting on a particle is directly proportional to the acceleration it produces. Can you write down that as a mathematical statement? Yes, F net force, is directly proportional to the acceleration A. And you know that whenever we make a statement like this in physics, the proportional sign can be replaced by an equal sign, and so you can say F net equal to a constant times the acceleration. And what is this constant in this case? It is the mass of that particle. So when a net force acts on a particle of mass m, an acceleration A is produced on the object such that the net force equal to mass multiplied by the acceleration. Look at the way we are now coming to quantify force, and therefore we can now measure force. This m is a constant and it is the mass of the object. Well, let's now talk about the unit for measuring a force. What is the unit in which you're going to measure force? Every physical quantity needs a unit for measurement, because you remember in the beginning, as I said, the nature of measurement is made clear by the unit of that quantity. When you say 2 meters, you know the measured quantity is length. When you say 5 meters per second squared, you know the measured quantity is acceleration. What is the unit for measuring force? let's write down the second law equation. The equation that describes the second law of motion is the net force F net equal to ma. Now, if you now take 1 kilogram and use sufficient force to produce an acceleration of 1 meter per second squared, you can see if m equal to 1 kilogram and acceleration is 1 meter per second squared, then 1 kilogram times 1 meter per second squared will be equal to 1 unit of force. Is that right? Yes. Now, so mass is measured in kilogram, acceleration is measured in meter per second squared. Therefore, it is easy to define a unit for force. What will be the unit for force? It will be kilogram multiplied by meter per second squared. This is the unit for measuring force. Kilogram meter per second squared. Now, this has a name, and that is called a Newton. 1 kilogram meter per second squared is called a Newton. And now, if I ask you, you have a fair idea how much is 1 kilogram, is that right? I have showed you here, I'm holding a mass of 1 kilogram. This is 1 kilogram mass. Now, the amount of force I need to apply on this to produce an acceleration of 1 meter per second squared, that much force is called 1 Newton. So the unit for measuring force is a Newton. Now, the amount of force that produces an acceleration of 1 meter per second squared on a particle of mass 1 kilogram is called 1 Newton. Well, I have a scale here that is marked in Newton. Let me see if I could show that to you. Now, here is a scale that is used for measuring force in Newton. Well, let me see if the camera will focus onto it. You can see, you can measure up to 10 Newton there, and I can apply a force on this. When I apply a force, you can see the force I'm applying is 2 Newton, 3 Newton, 4 Newton, 5, and so on. I can measure force in Newton using this. Now, I'm going to hang a kilogram. Look at this. This is a kilogram from the scale. Now, tell me, what is the force that is stretching the spring now? It's about 10 Newton. That means this 1 kilogram is pulling the spring now with a force of 10 Newton. All right. I'm now going to put a 100 gram in there, and can you tell me what is the force that is read there? Well, the force is 1 Newton. So can you get a feeling of how much is 1 Newton? Here I have a mass of 100 gram hanging from the spring, and the force this applies when it is hanging is 1 Newton. We will look at this as we go on. Let's now look at the difference between mass of an object and its weight. Now, very often this is confused by even scientists, because if I ask a scientist, hey scientist, what is your weight? I know in America, invariably, he will tell me 150 pounds. Well, pounds in English units, that is the old unit, apparently it is still used in America, is used for measuring mass and not for measuring weight. In SI system, the unit for measuring mass is a kilogram. Now, what is the difference between mass and weight? Let's discover that. Now, it is the mass of an object that determines its inertia. You see, a massive object, it is very difficult to move it, whereas a light object, you can easily move it. Therefore, mass of an object can be simply defined as its inertia, the amount of inertia. Is that right? Now, you have a great big box. It takes a great amount of effort to move it. You see that? It has a great inertia. Whereas a golf ball, well, even a child can move a golf ball. The inertia of the golf ball is very small. The amount of matter in the golf ball is very small. Whereas the amount of matter in this box is very great. It has a greater inertia. Therefore, we are going to define mass as a measure of the inertia of the object. That's a very convenient way to define mass. If you now look at these two masses, I have two masses here, which has greater inertia? Well, the one on my left hand, when you watch it, it'll look like my right hand. Well, this has a greater mass because it has a greater inertia. This has a lesser mass, it has less inertia. So, mass is a measure of the inertia of an object or a particle. Whereas, weight is something that makes an object fall. Well, if this object has no weight, it cannot fall. When I drop it, it falls because it has weight. So, weight is an object that makes object fall. What does that mean? What does the process of falling means? Now, if I have a basketball here, it is at rest here. Falling means it is changing its state of rest. So what is making the ball fall? When I take my hand off, there is a net force that is pulling the ball towards the earth. It is called the force of gravity. Is that right? So it is the force of gravity acting on this object that is going to make it move. In other words, weight is a force. It is the weight that makes the object fall. And what is weight? It is the pull on the object by the earth. It's a force of gravity. Now, weight is a measure of the force an object experiences due to the gravitational pull of the earth on it. So, whereas mass is a measure of inertia of an object, weight is a force. You see, very different things. That means if a force is acting on an object, that force must produce an acceleration. The net force on a freely falling object is called its weight. And now remember, whenever there is a net force, when the object falls under the action of that net force will produce an acceleration. That means the moment I let it go, it is going to accelerate. That means the weight of an object will make it accelerate. And the acceleration produced by the weight of an object, or the acceleration produced by the force of gravity on an object, is called the acceleration of free fall, and we will represent it by negative g. Why the negative sign? The negative sign indicates that the acceleration is directed downward. Now, in place of A, we will use negative g to represent the acceleration of free fall. So, if F net equal to ma, if this a is replaced by this negative g, what will that F net be? That F net will then be the weight of the object, the force on the object due to the gravity of the earth. Therefore, if a is replaced by negative g, weight becomes m times negative g or negative mg. The weight of this object is negative mg. It is directed downwards, where m is the mass and g is the acceleration caused by the force of gravity. So here, when it falls under the action of that net force, which is m times g. Well, the negative sign indicates that the direction of the weight of the force is downward. Mass is a scalar quantity. Mass of an object has no direction. It is simply a measure of the inertia of that object. We measure it in kilogram, whereas weight is a force and we measure it in Newton. Now, I measured my mass about a couple of minutes ago. My mass is 54 kilograms. All right? My mass m is 54 kilograms. Can you tell me what is my weight? Is my weight the same as this? Can I say my weight is 54 kilograms? Well, that is what many people say these days, but that is wrong. 54 kilogram is the unit of mass. That is my mass. My weight will be 54 kilogram times negative g. That will be negative 54 g. My weight W will be negative 54 g. If I can measure this g, then I know what my weight is. What is the unit for measuring my weight? Weight is a force. The unit is Newton. So you can only report your weight in Newton, not in kilogram, not in pounds. Weight is a force and its unit is the Newton. I hope you understand and don't confuse it again. Alright, let's now talk about the third law of motion. Now we talked about two laws now. The first law enabled us to define force. We said force is something that changes the state of rest or the state of uniform motion of an object. The second law enabled us to measure force. Well, before we go to third law, let me say something about the acceleration caused by the force of gravity. Now that can be measured very easily. What all you need to do is drop an object, measure the time taken for it to fall to the ground, and you can calculate. Now you know that the time taken, do you remember this? The time taken for an object to fall through a height h is square root of 2h over g. We talked about that in projectile motion. That means t squared equal to 2h over g, or g equal to 2h divided by t squared. So in order to measure acceleration due to gravity, what all I need to do is to take this basketball to a fairly high place, and I start a clock at the same time, drop it. When it hits the ground, stop the clock, measure that time, and measure the height through which the ball fell, you can calculate the value of G. G equal to 2h over t squared. Now, it is being calculated, and you will actually do that in the labs. And its value has been obtained as 9.8 meter per second squared. So if G is 9.8 meter per second squared, can you tell me what is my weight? My mass is 54 kilogram, and therefore my weight will be 54 times 9.8 Newton. Will be 54 kilogram times 9.8, which will be approximately, I think, 530 Newton. So my weight is approximately 530 Newton. You can see I haven't used the negative sign here. Well, because I was only interested in the magnitude. But when you use G for calculation for problems, it is a vector. Weight is a vector. So you must use the direction there as well. Okay. Alright, let's go back and talk about the third law of motion. Now, what does the third law talks about? It's a very common law. Many people know it. Now, the third law states that forces always come in pairs. Well, forces always come in pairs. What are the force pairs in this case? I'm applying a force upward, and this mass is pulling me down. There is a force pair here. Well, the law says all forces come in pairs. What does that mean? Now, here I have a girl who is meditating. What are the forces acting on her? Can you tell me, are there any forces acting on her? Certainly yes. Well, first of all, she has a weight. What is the direction of weight? Weight is always a force that is acting vertically down. So there is a force that wants to pull her down. Now, why isn't she going down? She's sitting on a platform actually. She's not in air. Well, the platform will apply a force upward. So, if the weight is the only force acting on her, she will be falling freely with an acceleration negative g meter per second squared. Well, since she is not doing that, there is another force acting on her, keeping her at rest. What is that force? This is the force applied by the floor directed upward on her. And this is called the force of reaction. And we also call it the normal force. What is the meaning of the normal force? It means that force is at right angles to the surface where she is sitting. You see that? That is why it's called the normal force. A normal is a perpendicular. So, when this mass is sitting on my hand, what are the two forces there? The weight of this mass is acting vertically down, and the force of reaction applied by my hand is the normal force vertically upward. And the magnitudes of these two forces are exactly the same. So you got the weight acting vertically down and the normal force acting vertically up. Now, Look at the force pairs on the box when the box is sitting on the floor. Here is a box. What are the force pairs on that box? The weight mg is acting vertically down, and the normal force N is acting vertically up. Now tell me, what is the net force on the box? The net force on the box is the sum of these two forces. N is a positive force, mg is a negative force. Therefore, the net force is N minus mg. And since there is no net force on the box, we can say N minus mg equal to 0, or N equal to mg. So you can see that the weight and the reaction forces are equal and opposite. Let's now look at some more reaction forces. Reaction forces come in many forms. We just looked at a couple of those. This is one form of a reaction force. When the object is sitting on a surface, the reaction force supports it. In other words, it balances the weight. Now, if my hand is not able to apply that reaction force, what will happen? The mass will keep falling. Now, why am I able to stand on the floor of the classroom? My weight is acting vertically down. If that is the only force on me, I will go straight to hell. Is that right? Yes, I would. Well, the floor will not allow me to do that. It supports me. So my weight is balanced by the normal force there. Now look at the traffic light. Now here is a traffic light there. I think some of it is blocked. You can see the traffic light is supported by two cables. Now the weight of the traffic light, now what are the forces acting on that traffic light, keeping it in position? Can you talk about some of the forces that are acting on this traffic light, keeping it in position? It is in equilibrium. What is the meaning that it is in equilibrium? Equilibrium is the state where the forces are balanced. That means no net force. When there is no net force, the object is either at rest or moving uniformly. The traffic light has to be at rest. That means the net force acting on it must be 0. The first and the important force there that you can identify is the weight of the light. That will be acting vertically down. Weight is mg, where m is the mass and of course g is the acceleration due to gravity. That acts vertically down. To prevent the light from falling freely, the cables apply forces upward. So there is a force on this cable on the left and this cable on the right. Now, these forces on the cable are called tension forces. If you stretch a spring, the spring applies a force backward. If you hang on a string, the string will support you as long as the tension on the string will hold up your weight. So the force on the cable is called the tension forces. That means there is a tension force on the left cable, and I'm going to call that tension force T1. And there is a tension force on the cable on the right, and I'm going to call that T2. Therefore, there are 3 forces acting on that light, keeping that in its position, keeping it in a state of equilibrium, in a state of balance. the vector sum of these three forces is 0. In other words, if you add the weight vector to the T1 vector to the T2 vector, the sum of those three force vectors will be 0. You can see here, we will be using the rules for vector addition to do these kind of things in problem solving. Now here, the action and reaction forces add to give you 0 because forces are acting on the same object, keeping at rest. So, the force pairs that we were talking about can be labeled as action forces and reaction forces. Now, if action forces and reaction forces are balanced, then we can actually make a statement of the third law. What is the statement of the third law? Action forces are balanced by the reaction forces. In other words, action is equal and opposite to reaction. That is actually the statement of the third law. Now tell me, what are the forces involved when a horse pulls a cart? Well, what we said is that action forces are equal and opposite to reaction forces. Well, take the case a horse is pulling a cart. Now, what is the action? The horse is pulling on the cart, is that right? Then shouldn't the cart pull the horse back? And if the action and reaction forces are balanced, that means that horse can never make the cart move. Now, do you understand what I'm saying? If action and reaction forces are equal and opposite, they cancel each other, then the force with which the horse is pulling the cart forward will be equal to the force with which the cart is pulling the horse back. That means the horse and the cart should be at perpetual rest. So why did we create the cart in the first place if the horse cannot move it? Can you explain the paradox here? What is the problem here? Well, do you see that the cart is tied to the horse? That means the horse and the cart forms a single system. So the action here is not the horse pulling the cart. The action here is the horse kicking the ground. See that? The horse is kicking the ground. That is the action. The horse kicks the ground backward with a force F sub K, the force of the kick. Now what is the reaction force here? The ground applies a force F sub R forward. In fact, in the absence of this reaction force, the horse and the cart will never be able to move. It is this reaction force that make the horse and the cart move forward. But then didn't we say that action and reaction forces always cancel each other? Well, yes, we did say that. But that is true only if the action and reaction forces act on the same object. In this case, the action, which is the weight, the reaction force, which is the normal force, are both on this mass. They cancel each other. But in the case of the horse and the cart, the action is by the horse on the earth. The horse doesn't like the earth. It keeps kicking the earth. You see that? That is the action. The action is the horse kicking the earth. What is the reaction? The reaction is the earth pushing the horse. It is a fight between the horse and the earth. Now tell me, how is it possible for you to walk? It's the same situation. When you want to walk, you kick the earth backward. The earth will push you forward. So it is a perpetual fight between people and the earth all the time. Thousands and thousands of people are kicking the earth. Now, shouldn't that kick move the earth? Well, we assume that because all these kicks are so random, the total effect of all that kicks will average out to be zero. So you kick the earth backward, the earth pushes you forward. If the earth doesn't push you forward, you will never be able to walk. Now try walking on a muddy place where it is full of mud. You put your foot down and your foot gets stuck. You see that? You cannot get the upward, the forward push from there. You can only walk on firm ground where the ground is able to push you forward. Now look at how a high jumper is able to jump. When the high jumper wants to jump, he pushes the earth down with a tremendous force downward and enabling the earth to lift him up. The merit doesn't go to the jumper, the merit goes to the earth actually. It is the earth that lifts up the high jumper. Well, of course, the merit goes to the jumper. You need to know how best to kick the earth. Alright, so action and reaction forces will cancel only if they are acting on the same object. In this case, they are not acting on the same object. When we walk, they are not acting on the same object. You see, force pairs are all over. They don't cancel very often because they are on two different objects. These two forces are on two different objects and they don't cancel. It is the reaction force of the ground that propels the horse and the cart forward. And it is the reaction force applied by the ground that makes it possible for us to walk on the ground. You see, look at the blessings of nature. If the earth one day refuses to push you forward, you will not be able to walk. So you must be thankful for all such blessings. Okay, when a rocket is fired, it is the reaction force of the exhausting gases that propels it forward. Now, the firing of the rocket will burn fuel and the exhaust will be pushed down, and the exhaust that is moving down will apply the reaction force upward, making the rocket to go. Now try blowing a balloon and leave it. You can see the air will come out of the balloon fast, the balloon will go back. It's the same principle as the rocket. Have you ever tried firing a gun? If you fire a .303, that's one of the old rifles. I have used one of those. Now, if you keep it on your shoulder and fire, the bullet goes very fast forward, that is the action. And in jumping out, the bullet will apply a reaction force backward. And you can actually feel it. If you don't keep the rifle properly, it can break your collarbone. So you must actually have training to use such rifles. Now, if you are in a boat, inside water, if you jump out of the boat, what happens to the boat? It'll go back. Action and reaction. When you jump forward, the reaction force takes the boat backward. Well, so all these illustrate that forces always come in pairs. But what I have done here is to lay the foundation for discussing the laws of motion. The three laws of motion. The first law, the law of inertia, helps us to define force. The second law enables us to measure force. And of course the third law says all forces come in pairs. Well, what we're going to do in the next part of this lesson is to use these concepts to solve problems.